Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's hard level puzzle. I don't know why I think I combined today and hard tried to combine that into a word, and that was obviously not good. This is today's hard level puzzle, and it's called Stickiest Notes by James Sinclair. And I've done both sticky and stickier notes, so I will be posting. I don't know if I can post two. I will be posting at least one of the puzzle solves in the corner here. Um, I don't know which one I'll be posting there, actually. Um, this is the third one and the hardest one of the sticky notes puzzles that James Sinclair has created. And they're very similar, actually. All right, they feel very similar, at least so far. Um, let's get to the rules. We have typical chaos construction rules where we need to divide the grid into 9 orthogonally connected 9-cell regions. And we need to place the digits 1 through 9 once in each row, column, and region. So what is an orthogonally connected region? It's something like this, where you can go from any cell in the region to any other cell in the region just by going through edges, excuse me, all while staying within the region. So to get from here to here, you can go from these edges all while staying in the region. What is an example of an invalid orthogonally connected region would be something like this, right? Where because these two cells cannot get to these cells over here by just going through edges while staying within the region. They have to go through a corner or get outside of the region through an edge. Even though they can get to each other by going through edges while staying in the region, you have to be able to go to every cell in the region just by going through edges while staying within the region. So that's why this does not work as an orthogonally connected region. And that's an example of how chaos construction works. Each region has a corresponding color. A note outside the grid indicates that the region of that color contains a run of one or more orthogonally connected cells, bounded on either side by a region border or the edge of the grid, in that row or column. And the number in the note, if given, is the sum of the digits in these cells. If a region contains multiple sets of orthogonally connected cells in the same row or column, a note only applies to one of them. So basically, for example, we see this has a pink 12 here. That means there must be a run of cells in this region orthogonally connected, which just means sharing an edge. It's basically like orthogonally connected region, though, I guess I would say. So you have a run of pink cells here, which must add up to 12. And you could have multiple pink cells in the region. Well, this is a little hard, though, with... yeah, it's going to be problematic because that's going to force this to not have a region, which every cell in the grid must have a region. But let's say we try to have... Let's do it with 12 here, the blue 12. You could have multiple runs of blue in this region, and the 12 note only applies to one of them. It does not apply to both of them. It does not apply to... it just doesn't apply to all blue cells, all blue runs in the row. It just applies to one of the runs. So the 12 is saying that there is a run of blue cells which adds up to 12, and that's all it says. The pink in this then means that it has a run of pink cells which sum must be greater than the 12 of the blue sum, of the blue that's given. So you could have also multiple pink runs here. That's also possible. So you could have, like, this pink run is adding up to 13, and this blue run adds up to 12, and that would satisfy these notes. Because again, if you have notes, wait, I haven't said that part yet. Okay. Well, when two notes overlap, the note above has a lower sum than the note below. And this applies even if a sum is hidden or not given. So because there's a pink below the blue post-it or sticky note there, that means this pink one, there must be a run of pink cells which has a sum greater than the blue region here, which is 12. And it also works for this, right? If you have, we have a dark green, which I think I'm going to label as light, because I don't have a dark green color. But, I mean, I do have a dark green color, but it's just easier to use light instead of dark green. But, say we had a dark green region, a sum here, right? There has to be a yellow sum in this row, which is greater than the dark green sum, or in this case would be light sum for me, right? So you could have something like 1, 2, 3, and 5, and then this could be 7 and 9. And this would be valid for the sticky notes, because for the dark green, which I have as light region, you have the sum 1, 2, 3, and 5, which adds up to 11, and then we have a yellow run of orthogonally connected cells, which adds up to greater than 11, which is 16. So that would satisfy this sticky notes. And that's when you have multiple notes overlapping each other. The note which has the lowest sum is the note on top. And each subsequent note must have a sum, must have a run that has a sum that's greater than the post-it note above it. So if you could actually have something along the lines of, say, light here, and then this is yellow. And this could be 1, 2, 3, 5. But if this were like 4 and this were like 6, that would work because we have a run here of the dark green region, which is only 4. And we have a run here in that row, which is greater than that run of 4. So that's an example of how these post-its, these sticky notes, can potentially work. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. So the ones that I think we want to look for the most restrictive sets. We have red in column 2 and red in column 8. So it's going to have to find 7 cells, and we know the red in column 2 has to be at least 2 digits, because it's greater than 14, which is the sum of digits in the dark green / light region I'm going to have it as. And in row, sorry, did I say row 2? Column 2. Column 2 and column 8. It has to have 7 cells to get across. It has to have 2 cells in column 2 because it must add up to at least 15, which is greater than 14. And it must have 2 digits in column 8 to add up to 17. Or, 13 at least, because it's greater than 12. Okay, we don't have red in any row, though. So we know there's 2 reds in column 2, there's 2 reds in column 8, and the rest must be just connecting those 2 columns. Well, where can the red 7 cell? It must be 7 across, because again, we don't have any extraneous red cells. Where can red go 7 across? Cannot go in row 1, because we need at least a 2-cell region for pink. Can't go in row 2 because we need a 2-cell region for 12, blue. It could be in 3, 4, 5, 6. Sorry, 3, 4, and 5. Rows 3, 4, and 5. It cannot... Well, it could be in 6 also. It could be 6, 7, 8, or 9. So red has to be in 3 through... in this box, essentially. Rows 3 through 9. Okay. We also have blue having to be in row 2 and row 8. So that's going to be connecting 7 there. We also know that there are 2 cells that are blue in row 2. At least, I should say. For the red, we know there's 2 in each in column 2 and column 8 because that's the only way to form a 9-cell region. For blue, you could have 2, 3. You can't have 4 because if you have 4, you can't get 7 down this way. So it's 3 at most. There's 1 or 2 blue cells in column 5. So it could be something like, it cannot be all blue here because that's too long, right? That's going to add up to greater than 4. And again, it can't go outside and then back in. It has to be, I guess it could do something. Can it do like that? I don't think so. Well, maybe. 1, 2, 3, 4, 5, 6, 7, 8, 9. It could do something like that. So that is possible. The problem with this, though, we have in column 4, 3 sets of 2-digit numbers. Right? Because you have to have yellow adding up to 13. Oh, that's going to be weird. Yellow adds up to 13, orange adds up to at least 14, and green adds up to at least 15. 13 plus 14 plus 15 is 42. We know we need a red going through here. So I don't think blue can never go through here more than just 1 cell. So either blue is 1 cell here. So blue could do something like that. That is potentially possible. But you can't have full... Okay, so you can't have all blue here because you have 15 in the column. So blue has to connect to here. You could go blue all 7 here, 7 there. It doesn't even have to be 7. Well, it does if it has to go if it's in column 3. If it's in column 3, it must connect to the blue here. It cannot connect this way, so it must be 3 blue here. So if this is going down in column 3, it must be all 7. You could do something like this in column 4, but the problem is we have 13, 14, and 15 at least in that column. So blue has to go somewhere between columns 3 and 7 to go down from row 2 to row 8. Red is never going to be able to cut across there. Cross through the blue, essentially. And blue does have to have some sort of combination that goes all the way down. So, okay, so Blue can't go down partially through 4. Blue can't go down through 3 because we need 2 orange cells adding up to 15 at least in orthogonally connected. And if you have blue going down this way, there's no way you can do that. Problem also with going down even a little bit in column 4. You can't do that because you have to have 3 other regions, adding up to 13, 14, and 15, which adds up to 42, which means there's only 2 possible digits left, 1 and 2 at most. And you have to have 3 cells in the blue region to make this work for 4 and go down a little bit here, right? Because if you try to go down this way, then this is one contiguous region of all blue. So to have one region being 4, it has to go something like this, and then this is impossible. So you could have row 6 or column 6 be where the blue is, or column 7 be where the blue is. And one of them has to have blue in them in some run. And it must get down to row 8. Well, red is not going to be able to go through that from rows 2 and 8. It can't go through row 1, so therefore the red must go through row 9. And then we have 2 reds here and then 2 reds here. And that's done as a region. So, yellow has to be one of these. We don't know which. This is red, which is greater than 14, so 6 through 9. This is red, which is greater than 12, which is 4 through 9. That means we are guaranteed 1, 2, and 3 here. Yellow has to be one of these, and it must be a 4. So this cannot have 4 here. We need a 4 somewhere in the red region. And it can't be here because of the yellow having to be red here, or yellow having to have a 4 here. And it's only a single digit because this has to be all red here. So where's 4 in the red region? It must be here, which makes that 4 and 9. That eliminates 9 from the rest of the red region. So this is 7, 8 as a pair. That means the remaining digits in the red region are 1, 2, 3, 5, and 6. That means blue cannot be 4 as a singleton. Blue has to have 2 digits adding up to 4 in row 8, which must be 1 and 3. So then this must be a full blue here or a full blue here. And it cannot be a full blue here because we have 2 digits here, we have 2 digits here. So this is blue here. This cannot, even if it goes this way, we need a sum adding up to 4, and you can't have a sum here. This has to be 1 and 3. Going either that way or that way. We're not sure, but we need a blue going this way to get to the 4 here. So that's 4. This is 8 to add up to 12. Remaining digits in the column, then, are 1 or 3. 5, 6, 7, 9. So 2, 5, 6, 7, 9 eliminates 2, 5, 6, 7, 9 in the rest of the column. So this is 1, 3, 1, 3 as a pair. That forces this to be a 4 there. So blue has a boundary this way. We don't know where the other 1, 3 is. It's either here or here for the blue. Remaining digits in row 9 are 4, 7, and 8. Remaining digits in row 8 are 2, 5, 6, 7, 8, and 9. Okay. So we don't know where yellow... Okay. Yellow cannot get through here to get to here. because it's blocked by blue. So if yellow were here, that doesn't work. So yellow has to be here. So yellow's here. Let's get the entire edge darkened in. Yellow must get to here, and then must have at least 2 digits. Yellow has to get to here. Okay. And this is a 4. So that eliminates 4 from being there. We have light green here. Light green has to also connect to this cell here. So this must be all light green. And light green has to have a run at least adding up. Oh, this can't be 3, 5, or 6. Light green has to have a run that's greater than 13. Or 14. So this is at least 15. So we have to have green, we have to have yellow. 1, 2, 3, 4, 5, 6, 7, 8. And then one of these is 9. So that is possible. We have dark here. Interesting. Dark has to get out somehow. So then we have to have 1 and 2 here. Dark is 1 or 2 getting out. So we have dark here. This must then be a combination of yellow, orange, and dark. Yellow, can yellow ever reach here? Probably not. And this could be green also. We don't know. No. Maybe. So green, orange, and yellow can all have 3 digits in them. We know we have 1 dark getting out here. We have a red here. Yellow has to cross. So we have dark here. Green here. We have red here. Orange. Orange has to get to here, but that's it. Blue is there, so that's done. How many regions is here? So we have dark green, yellow, orange, and dark gray, guaranteed. So again, dark green, yellow, orange, and dark gray. And then we have a little bit of the green. So dark green, yellow, orange, and dark gray is 4. How many cells do we have? This is 9, 16, plus 8 is 24, plus 12 is 36. Aha! And we have to have all those, we have 4 regions guaranteed in that cell. So this cannot be more green. So this has to be some combination of the dark green, the yellow, the orange, and dark. Because dark cannot go across here, therefore this cannot be blue. Therefore this must be blue that way, right? So this is, again, 36 cells, not including the green here, which is required. So that's 9 plus 7, 16, plus 8 is 24, plus 12 is 36, which is exactly 4 regions worth. And we have 4 regions in that region. So we have dark here. You could have yellow and orange here, potentially. And then dark has to get, well, we don't know how much it can go 1 here. So there must be some dark here. We have dark, light. I'm going to be for light for the green. This can't be light here. We can have yellow and orange. Therefore, this is guaranteed to be green here. That's done as a region. That means pink has to be some sort of things here. Green has to get to here. We need pink here. So this must be 2 pinks to add up to 12 because there's no other way to get pink out. This must have 2 pinks also, so that's double pink there. Green has to extend there. We have 1, 2, 3, 4, 5, 6, 7. We need 2 more greens here to add up to 12. So this is green, green. Pink has to get out that way. Medium gray has to get out to here. So this is done as a region. Green is done as a region. So then pink has... So this is 5. Because that's the only pink cell in that row. This adds up to 12. It's 3, 9, or 4, 8. It cannot be 4, 8 because of the 4 in the row. This adds up to greater than 12. So it's at least 13. There's no 4 or 8 here. So this, and it can't be 5, 3, or 9. So this has to be 6, 7 as a pair to add up to greater than 12. Dark has to go, medium has to go to here. And this cannot be pink because if this is pink, well, can't reach there. That's 7. So then this must be medium here. Medium has to go down here. You have pink going 1, 2, or 3. And then medium could be any of these. So 1, 2, 3, 4, 5, 6, 7, 8. You could have medium there, medium there. So this is 1 or 3 here. No 5 here. Remaining digits of the pink region are 1, 2, and 4. 9 eliminates 9 here, so this is 3, which makes this 9. This adds up to 12 without 3, 9, or 4, so this is 5 and 7, which makes this 5 and that 7 because this can't be 5 here. That makes this 6 and 7 there. Remaining digits in column... Oh, it's not 1, 2. It's 1, 2, 4, and 8 for the pink. Okay. Remaining digits in column 8 are 1, 2, and 8. 9 cannot be here. We need a 9 in the medium dark region. And 9 cannot be here. We need 5 and 7. So this has to have 5, 7, and 9 here. Green already has 5 and 7. 9 can't be here. 9 can't be here. Where is 9 in the green region? It must be there. So this cannot have 5 here. Where is 4 in column 7? Can't be in the green region. Can't be either of these. So this has to be 4, 5, 7, and 9 then. Which means the rest of the 7 eliminates 7 here. So this is 8, which makes this 7, which makes that 8, which eliminates 8 from the rest of the row. This can't be 7 because of 7 in the column. 8 eliminates 8 from the rest of the column and the rest of the medium gray region. Rest of column 9 is 1, 2, 3, 4, and 6. So 3 is one of these two for the medium gray. We also need 6 for the medium gray, but it could be here. Remaining digits in row 9, 2, 5, 6, 7, 9. So remaining digits in the green region. Well, 3 can't be here. 3 has to be one of these. So this can't be 3. It's 1, which makes this 3, which makes that 1, which makes that 2. So no 1, 2 here, no 1, 2 here, no 1, 2 here. This can't be 3 because 3 has to be one of these two for the greens, which means this is 6. Which means this can't be 6 here, this can't be 6 here. Remaining digits in column 7 are 2, 3, and 8. There's obviously no 3 here. 2, 3, 8 eliminates 2, 3, 8 in the rest of the green region. So this must be 1 and 6. 2 eliminates 2 here. The other digit that's here, so this must be 15. So this is 6 and 9, which makes that 1. So this cannot be 6 or 9 here. 4 here. 1 here. Remaining digits in row 1. We have 2, 5, 7, and 8. Okay. We have at least 2 oranges here. If you don't have 2 oranges here, it's not going to be greater than 12. So therefore, this is orange. And it could be all 3 are orange, or it could be only 2 of them are orange. We don't know which. 7 and 8 eliminates 7 and 8 here. So, if... it could be 5 and 8 here. Or 5, 2, 5, and 7 also work. Okay. Orange is definitely here, though, and cannot reach here. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So it could reach orange here. It cannot reach orange here. So this is yellow or dark. Dark has 1 cell going through here, and it's a 1. Medium must add up to 8 here. So then this must be medium, which eliminates medium from the rest of the region. So this has to be 8 as a pink. This cannot be 3 or 6. We have a 1, 2, 4 triplet in column. This can't be 8 here. This adds up to 8 here, so it must be 1 and 7. So that's 1, 7. This is 2. That's 6. That's 3. No more 7 here. No 7 here. So this is done as a region. So no 7 here. No 7 here. Remaining digits of row 2. We have 1, 2, 3, and 8. No, this 8 eliminates 8 here. 1, 2, 3, and 5. Okay. So this is done. The 12 is done. The 13 is done. The 12 here is done. The orange is not done here. 12 is done here. 13 is done here. The medium gray is done there. The dark, we haven't quite finished that. We know yellow is 13. Orange must be 14. And it cannot be 5, 9, or 6, 8. So orange has 3 cells in column 4. Dark has 1, which is 1. Yellow must have 2 cells in, adding up to 13. Which would be not 6, 7, not 4, 9. It's 5, 8. So then orange is 3, 4, and 7. Interesting. Anyways, 2 eliminates 2 here. So this adds up to 8, so that's done. We don't have anything about the light region here. We just know that the yellow region is larger than the light region here. We have the 4 adding up for the blue. We have the 4 adding up for the yellow. We have 15 here. We don't have the light region yet adding up to 14. Orange adds up to 15 here. So 15 plus 14. Okay. 1 eliminates 1 here. 6 eliminates 6 in the rest of the row. Remaining digits of row 7, we have 1, 4, 5, 6, 7, 8, 9. Obviously no 7, 8 here, no 4 in the column here. If this is 5, it has to be with 8 here. If this is 7, it can be with 3 or 4. But it would have to be 4 here then, because 3 cannot be there. This can't be orange. So since this can't be orange, it can't be dark either. This has to be yellow. So yellow adds up. It must be there. So this is yellow, which means this is 5 and 8. That eliminates 8 in the rest of the row. And 5 in the rest of the row. That means all of this has to be yellow. Because if it's another color, there's no way that it can fit inside of the yellow trying to connect orthogonally with itself. So this is all yellow then. Because orange, cannot reach there. And then dark can only be 1 going this way. So this is yellow, which means none of these are yellow. So we have to have orange be 2 of the digits connecting to the third. So orange is one of these two, which is 3, 4, and 7 again. This can't be 7 because of 7 in the row. Remaining digits are 1, 3, 4, 7. 1, 3, 4, 7. No 7 there. Okay, 1 and 4 eliminate 1 and 4 here. So 5 eliminates 5 in the rest of the yellow region. We have 1, 2, 3, 4, 5, 6, 7, 8. We are guaranteed a yellow here, so none of these can be yellow. So these are all dark. This has to connect orthogonally to the dark, so that's dark. One of these 3 is yellow. That means the rest of the grid cannot contain yellow. Okay. We need a 3 in the yellow, which means the light is only one color, one cell here too, and it must be 1 or 2. So this can't be 4 here. We have 1, 6, 7, 8, 9 in the yellow region. 6 has to be here, and 1 has to be here. So that eliminates 6 and 1 in the rest of the row. Where is 4 in row 7? Can't be in the yellow region, can't be here because the 4 is in the column. So 4 has to be here, which means this can't be 4. There's no 4 here. We are guaranteed a 3 in the yellow region here, which means this cannot be 3 here. We're guaranteed one of these is 5. We don't know which. Okay, so this is boundary. 3 is here. That means we have 1 or 2 here as the light. And we don't know what the other color is. Because the light must be less than the yellow, and we know the yellow here is 3. Okay. Um, hmm. So we know one of these is a 5. This can't be 5. Oh, 5 eliminates 5 here, so that's 9, which makes that 5. Therefore, there's no 5 or 9 here. There's no 5 here. Remaining digits of column 5. We have 2, 3, 5, 6, 7, 8, 9. No 9 or 5 here. No 7 here. No 7 here. No 5 here. Hmm. Um. Hmm. Uh. 1, 1, 2, 3, 4, 5, 6, 7. So you could have at most 2 more here. So 1, 2, 3, 4, 5, 6, 7, or 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. You can only have at most 1 orange here. So I think both of these have to be dark. Right? Because if you have 1 orange here, then this dark cannot get around to get to here. So these have to be dark. This could be dark also. So this is 3, 4, and 7 for the orange. Oh. That means 7 cannot be in the orange here. Right, for yellow, to add up to 14 with 2 oranges would be 5, 9, or 6, 8, which are both eliminated because of the 6, 9 in the column. So it has to be 3 digits adding up to orange and 2 digits adding up to yellow. That eliminates 6, 7, 4, 9. So it must be 5, 8 for the yellow. Orange can't reach here, so therefore this must be yellow adding up because this could not be 1. So therefore it's 5 and 8. And 3, 4, 7 is in the orange. Therefore 7 cannot be in the orange here, which means it must be 5 and 8. Which means this can't be 8. It's 2, which makes this 3, which makes that 8. That eliminates 8 and 5 here. So this 2 eliminates 2 here, so this is 5. No 2 or 5 here, no 2 or 5 here, it's 7 or 8. That means this can't be 5. This can't be 3 here. Can this be orange, orange here? If this is some other color, I guess 1, 2, 3, 4, 5, 6, 7, 8, 9. And then this is 6, but that's too few. That's too many. So if we have 1, 2, that means this is a different color. But then this would be 10 cells for the dark region because orange has to block that. So this cannot be orange. which means this is 7, and this is 8. That eliminates 7 in the rest of the column. This is orange. Can you do something like this then? So say we have dark going this way. So that's 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. But then this is not going to add up to 15. So this cannot be dark going this way. It must be orange there. So this is dark. So this must be 1. This cannot be 1. It's 3, 4 as a pair, which eliminates 3, 4 in the rest of the box. This can't be 3, 4, or rest of the column. This can't be 3 or 4. It's 7, which eliminates 7 here. So to add up to 15 for orange, you cannot have 8. It has to be 8, 1, and 6. So therefore, this is all orange here. And this must be 1, 6 here. That means this can't be orange here. That's done. This can't be 1. It's 2, which makes this 5. This can't be dark, so it must be light, because dark can't reach there. 1 through 6... 7, 8, and 9. So it can reach to there. So these are all dark. Or sorry, these cannot be dark. 1, 2, 3, 4, 5, 6, 7, 8. 7, 8, and 9, or 8, 9. It can't be all of these. So dark can't reach there. Dark can't reach there because, again, so dark has to get out here. So this is dark, which means this is a light yellow pair. One of these is 3. 1 is here, so this can't be 1, which means this is 2 and 3 here. So that's 2, 3 as a pair, which eliminates 2 and 3 in the rest of the row. That means this can't be 1 or 2. It's 4, which makes that 2, which makes that 1. This can't be 2 or 3 again. No 8, no 2. That's 6, 7, 9 as a triplet in row 6. 2 eliminates 2 here, so that's 3, which makes that 2. Yellow has to have the 3, so this is not light. That's yellow. This can't be yellow, so that's light, which means this can't be... This has to all be light here. Light, this 2 eliminates 2 here, so this is 9, which eliminates 9 in the rest of the yellow region. This can't be 1 or 6. It's 7. That makes this 2 here. No 6 or 7 here. It's 9, which eliminates 9 in the rest of the row. These can't be 7. This can't be 2 or 9. Therefore, that's 7, which means this can't be 7. That's 6 and 7 there. No 6 here. No 7 here. No 6 there. No 9 in the dark region. So this can't be 9. This is 5, which makes this 9. 5 eliminates 5 here, so it's 3 and 5. No more 5 here or 3. No 3 here. This cannot be 9. This is 2, 8 as a pair. 2 and 3. Eliminate 2 and 3 here. It's 9. This can't be 9 or 6. It's 2, which makes this 6. This has to be 5 then. This cannot be dark because the dark has to go out this way. So this is orange. And the orange needs access to a 2, which can only reach here. So then this is not light. This is orange. Dark has to get out here then. So it's 1, 2, 3, 4, 5, 6, 7. That's 8, and then it gets to one of these. So orange cannot be any of these. Therefore, this is light. Can you get 2 digits adding up to 14 here? The answer is no. So it must be 3 digits adding up to 14 here. So this is not dark, because 14 would be 5 or 5 and 9 or 6 and 8, but we have a 5 and an 8 in the column. So these 3 digits must add up to 14. This is done as a region. This is done as a region. This is not light. we have remaining digits in the dark region are 3 and 4. These three add up to 14. We are guaranteed a 9 here and a 4. So 9, 4, and 1 add up to 14. This can't be 1 or 9 because of 1 and 9 in the row, so it's 4. This can't be 1 because of 1 in the row, so this is 9, which makes that 1, which makes this 6, that 1. 4 eliminates 4 here, so it's 3 and 4. 2 eliminates 2 here, so it's 8 and 2. 4 eliminates 4 here, so it's 3 and 4. That leaves this digit as a 3, this digit as an 8, and this digit as a 6. And that's a solution. I felt like this was actually easier than the stickier notes, which was supposed to be challenging level. I don't know. It felt like that these were really restrictive, I guess. I don't know. Maybe it's just because I've done the other ones before, so that makes it easier for me to spot these now. I don't know. Maybe. Anyways, let's check the notes. We have 3, 9 adding up to 12, 5, 8 adding up to 13, which is greater than 12, 4, 8 adding up to 12 for the blue, 6 and 7, which adds up to 13, which is greater than the blue, 5 adding up to 5, 1, 7 adding up to 8 for the medium dark, for the medium gray. Light is 2, which is in there. 3, yellow is 3, which is greater than 2. 1 and 3 add up to 4 for the blue. 4 is yellow. We have 1, 4, 9 adding up to 14 for the light/dark green region. And 7, 8 adds up to 15, which is greater than 14. 1, 8, 6, which adds up to 15 for the orange region. 5, 8 adding up to 13 for the yellow. 3, 4, 7 adding up to 14 for the orange, which is greater than 13. And 6, 9, which is adding up to 15, which is greater than the orange. We have 4 for the blue, and dark is much greater than that. 5, 7 for the green, which adds up to 12, and 4, 9 adds up to 13, which is greater than the 12, and we have medium here. Yeah. I don't know, for some reason, this felt easier for me than the last one, than the stickier notes. But again, like I have now had 2 other puzzles where I've tried to figure this out. So, I don't know. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.